So, do we need a USB Type-C cable tester? I don't know about you guys, but just of late I've been buying some devices and so on, and everything seems to be coming with these USB-C Type-C connectors on them, and which is good because, you know, they are much easier to use, more robust than those horrible micro C type or micro B, whatever they were called, USB 3 plugs that were ubiquitous, you know, even 5, 6, 7 years ago, and I've got a ton of those laying around, and it is definitely more robust and a better plug for most uses. However, in the old days, you know, USB-C has been around since the early 90s. Originally, they were developed for like Microsoft mouse and a keyboard, and by some Intel engineers. And since then, of course, a lot has happened. We went to USB 2, and USB 2 made it a little faster, but it always had, like, this is a, if you bought a USB style cable before, it would always have 4 wires in it, plus 5 volts ground and plus and minus D. It was for the serial signal. So then we went to USB 3, and of course the throughput went up to 480 megabits per second. USB 3 added a few wires to it, but you would have a blue plug, so you would recognize that we are talking about USB 3. For instance, you know, you've probably seen it. There's one here, you see it's blue inside, so at least you knew, and the socket would be blue as well, so at least you knew that if you wanted to use 3USB through with its higher throughput, you would grab a cable that had these blue little tongues in them. Now, however, the situation has changed. When we were talking about USB 3 Type-C, there can be up to 24 wires in the plug. There's a good article about USB-C in the All About Circuits website. There'll be a link in the description below, and as you can see, and there's a Type-C plug, and one of the features is now that the same looking cable, it could have USB Type-C plugs either on both ends, or one end and a Type A on the other end. It could be only a USB 2 cable. It's just supporting the old USB 2 signals, the 4 wires in other words. Or it could be USB 3, or it could be USB 3.1 Gen 2. But there's more than that. There's also a so-called alternate mode, which means that the actual cable, and it won't look any different necessarily, it could be supporting DisplayPort or HDMI or Thunderbolt, or a thing called Mobile High Definition Link, or even PCIe, external PCI, for like a hard drive. So therefore the plugs and the sockets has up to 24 wires in it, and they have different purposes, and so some cables may or may not have all of these wires in it, or may not. Therefore you need to know now what kind of cable it is and use the appropriate cable for the appropriate device. If you are plugging this a cable into a high-speed device that might be expecting to transfer data up to 20 megabits per second, then you would have to have all of these pins connected. for instance, if it was just a USB 2 signal cable with Type C plugs on either end, or at least on one end, it might just have the D minus and the D plus, and this is the actual plug, and it would have some ground, and it would have V bus, which is the 5 volts, and that is what you would be seeing, and it would just be like that cable that would have just 4 wires basically. Note that interesting thing is that the plug only has the D minus and D plus on one side, but that doesn't matter, because if it's flipped upside down, it'll still find the receptacle has it duplicated, so that still works, and you'll see that once we have a look at that board and test some of our cables. So roughly, I think I've done another video on USB, and I went a little bit further into some of the descriptions here, but roughly what actually happens is there is a CC1 and a CC2, which are usually used for negotiating for power delivery, negotiating the different voltages. It might be actually asking for 20 volts at 3 amps, which is a PD 65 watts, or it could be asking for 5 amps at 20 volts. It would be a 100 watts, PD 100 watts power delivery specification. And in that case, there are also now cables coming out. I don't have any here to actually test, that have chips in them. They may amplify the actual signals to make the cable more accurate at higher signal speeds, like the 20 megabits and so on. Or they can actually identify themselves, that have an ID on them that the device or the software might use. And in that case, you'll see like there's a VCon connection here, which if I understand it correctly, it always has 5 volts on it in that case, and the chip in the cable will get its voltage from there, but the V bus might be actually negotiating a much higher voltage for the actual power delivery. We're talking about SPU and SPU2. They are potentially signals used by those alternate modes. And then we have 2 extra data lanes, TX1, RX1, TX2, RX2, which on a 20 gigabit cable would be enabled, so they'd be passing data in all of those lanes, including probably D minus and D plus. So in any case, there's a lot going on in these potentially in these cables, and different cables would have different ones of these pins enabled, and wires in the plug in the cables connected to these things. But there's many cables that would only have a subset of those, and you simply need to know what the cable is meant to do and what the capabilities of the cable is now, because there is not necessarily any way to tell. Although according to the specifications there is supposed to be a logo on the socket and on the plug, but some of the cables I have here are not actually following that standard as yet. See, like this cable for instance tells you it's a super speed one, and it can handle 20 gigabits per second. So this one we would expect all of the pins to be connected. And then I have some other ones that simply have super speed on them, but it doesn't have a 10 or a 20, so you would expect to have 5 gigabits throughput, and it may not have both of those data lanes connected. And then you would have some that are marked super speed 10, if you can see it. So this is a 10 gigabit cable, not a 20. So we're going to have a look at those and see how that little board might identify those. And some cables that I have actually do not have an identification on the plug, like here it is blank. But if you look at the actual cable itself, it actually says super high speed USB revision 3.1. So if that's the case, you would expect to have at least 10 gigabits per second throughput. So we'll have a look at those cables. This cable actually, and another one that I have, actually came with an Asus display where you can run the whole display on USB 3. Okay, so let's have a look what we can find out with this little board. Now this board also is going to be useful for testing for faulty cables that are not working properly. But first let's have a look at this is a cable. Of course they will get tangled up. This is a cable that came with a device for charging, and when you look at it, it has like a USB symbol on there, and it has the typical USB-C plug on the end. And if you look inside, you see all the little pins are present. So you might think by yourself, well, maybe that is a cable that I can use for data as well. But when you plug it in, you will find out that it only has ground and V-bus. It just has power, nothing else. And it doesn't have the CC pins connected either, so therefore it can't even negotiate a different voltage. It's just going to be a 5-volt cable. And interestingly enough, the shield also is not connected. The shield is, the outside metal on both the plugs that on high-speed cables would be connected to shield the cable from interference. And if the cable was one, as I said, I don't have any. If it had an ID chip in it, this would be lighting up as well, I understand. Now, this little board actually has most known connectors on it. It actually came with a little manual. And as you can see, it has a I can hold it so it's not glaring. USB port A, a type A3, a type A, USB 2, a type C, USB 3. That's kind of one end of the cable goes into there, and it optionally runs on a battery, so it has a power switch or that V-in port over here. And then on the other end there is a USB port B. That's that chunky one that you will, in the old days, used to be on printers and stuff, but there is a USB 3 version as well, and I've never personally had any devices with that particular plug on it. Then there is a USB type C3, there is a micro B3, there's a mini B2, which is this one here, and then there is a lightning connector, which is this one here, and there's a micro B2. You will probably recognize those. Probably 10 years ago or something, you might get devices with USB 2 that had that funny shaped plug on it, and these ones here, the micro B version 3, is actually ubiquitous. I got literally dozens of little cables from devices and things. I had those in there. I'm not particularly fond of those. They tend to be fragile. And this thing over here that weird shaped one. I've had a couple of hard drives with those on there, and in fact they always used to be very tricky. I've had two of them fail on me over time that didn't make a good contact, or they weren't, and this is one of them. This is actually a faulty one. So you see there's that plug that looks like that, and plug that in there, and then you plug that. It's actually a USB 3, so we'll stick it in the USB 3 socket. Oh, it's upside down. And so you see that this particular thing, given that it was aimed at a hard drive, it's got ground, and it does have the extra channels on there, RX1 and TX2, and D minus and D plus. However, and it has the 1V bus and of course ground, but I know for a fact that this, you see when I move this plug, it's bad. I had to replace this one because the hard drive was occasionally, it stopped working. So again, you can actually test cables using this device by some reason this plug gets really tight in there. You can test your cables using that thing, and I had another bad cable, which I'll put a snippet in here from another video where I was testing that one. And here too, this is a cable which was actually a giveaway by one of the local credit unions. It is actually gone faulty. It has adapters here for, see, micro USB and a lightning connector and a USB-C. So we will plug it in here and use the USB-C. There you go. See, it's only it's a bad cable. You wiggle it and some stuff connects and some stuff doesn't. Doesn't even have ground. So that is also how you can use this thing to recognize bad cables. Green one. Any case, so let's start at the top end. So we've already tested this cable here and decided this was a charge only cable, and I realized that already a while ago, so I actually wrote it on there, charge only. So this one, as already shown, is the actual, it's a USB-C to USB-C, and it's supposed to be fully fledged 20 gigabit cable, and you can plug that in, and indeed every single pin on this, all 24 pins are connected. So we got the ground, the extra data lanes, and the CC1, CC2, etc, etc. And the only things that are not lit up are these D minus and D plus. And remember, I showed you that the actual cable only has it on one end, which is exactly what this is showing, and that is fine. If I turn it around now, plug it in the other way, you see now these are not lit up and these are lit up, so that's perfectly normal. So this is a good cable, and it is a 20 gigabit one. This one here, it says it's a 10 gigabit cable, and as I said, it came with a an Asus display as well. Came with two cables. This is one of them. This is a and it was marked as a USB Gen 3.1 USB 3.1 Gen 2. And here is a Gen 1, Gen 2. You see what I mean? There's all these different cables, and you don't necessarily know what the difference is. So with this little board you can double check if the cable is good and also what it is actually supporting. And so this one, being that it is a 10 gigabit, it only implements one extra lane. See, RX1 and TX1. It does not implement the second one like the 20 gigabyte one did. And it also has a few differences. The CC1 line is there, but the CC2, oh yeah, it's CC2, no, CC2 is not on. So I am not 100% sure, but that might tell us that this cable is a 10 gigabit one or something instead of a 20, because I've seen this on some other cables. So that is the one that came from Asus, and that is the and is marked as 10 gigabits. It's interesting, and I've got a couple more like that, like this one here too came with that same monitor, and this one is USB-C to USB-C, and I think it shows a similar behavior. Yeah, well, this one actually has both lanes, but it also does not have the CC2 pin lit up. So I must try this later on. I'm going to try this with one of my little test boards to see what happens when you plug it into there, if it's still able to negotiate a voltage, because I don't think I've seen any literature on how these I always expect CC1 and CC2 to be there, but obviously in some cables they did not connect it. And as I said, these are special Asus cables that came with a display, so maybe they using that to identify the cable. I have no idea. So then we have cables that are actually specifically marked. This one here is marked as 100 watts. So these are cables, and it's got a little display on there. When you plug it in, it is supposed to show the wattage that it is drawing. But this particular cable, therefore, is actually aimed for charging more than for data delivery. And when you plug that in, let me undo this a little bit here to get me more slack, otherwise I can't plug it in. So this one has quite a different array. So we are seeing ground. We do not have TX2. We do not have the RX1. So it doesn't have the extra data lanes. So it's only, this is going to max out at 480 megabits. It has D1 and D minus VBus, but it does have CC2 and CC1. Because as I said, I expect those to be there, that they are used to negotiate extra voltage. And with this being a 100 watt cable, it would have to be able to handle 20 volts at 5 amps. Okay, so definitely this is a charging cable, and you wouldn't want to use that on your high-speed SSD or something like that. Again, as I said, you need to, with this little board, you can actually double check. Let me bring in the other camera there so you can see a little bit more wider angle what I'm doing as well. Here is a cable that came with a keyboard, so I am only expecting this to be a type 2, because after all a keyboard doesn't need much. And indeed we are looking at ground 5 volts and just ordinary D minus D plus. Yeah, it's just all it is a even though it has a type C plug on it, it is only a USB 2 cable. Then I have this strange one here. I got these cheap, they were on clearance one time, and I like this one because I use it to charge my keyboard, and it has an offset plug on it. But for some reason it has some symbol on there which I have no clue what it means. Any one of you do, put it in the description. This one says U, and on the other end of it, it's type C to type C. It has one or INIU. Don't know what that means. And this particular one is actually also just actually a USB 2 cable, but it does have the CC1 and CC2, so it could potentially negotiate a different voltage, but it is also not a high-speed cable. But perfectly right for a keyboard. And similarly, it looks like most of the USB-C cables that I have somehow that came with stuff, it's just marked with that little symbol on there, and I guess it doesn't say super speed, so it gives you a clue that, and it's not a blue one, so it's actually already gives you a clue that it is only a yeah, it's all it is a USB 2 standard cable. Now this one here, like the other one, let me undo the thing. Let me see where. Okay, this one too has no symbols on the plugs, but the actual cable is capable at least of, it says USB 3 cable, USB 3.1 cable, and some other stuff up to 30 volts. So you would, once you've received this cable with something, you would be wondering, you know, what's the USB 3.1, and in actual fact, see, it's interesting here that it actually has all the pins connected. It has the two high-speed lanes as well, but again, it has one of the CC plugs, the wires missing, and that's the third cable that I have like that. And if I plug it in the other way, then now you see it says CC2 is not on. So one of the CC is missing, is not connected. I'm starting to wonder why that is. I have not seen any information on that. As I said, if any of you guys know, put it in the description, because it would be interesting to know. Okay, so I decided to do a little bit of research on some of these cables where we saw that the CC1 or CC2 pins are not connected and so on. And I've got the multimeter connected so we can measure voltages, because those CC1 and CC2 pins are supposed to be involved with negotiating voltages as far as I understand it. So you'll be able to see what voltage that we will measure on the top left hand corner. So we have this little test board over here that actually has a switch on it, and you can set it to 5 volts, 9 volts, 12 volts, 15 volts or 20 volts. Well, I have it set to 20 volts, and we're going to be plugging some of these cables in and see what it comes up with. So first of all, we have that proper power cable here that we have looked at before, that appears to have all the necessary pins connected for CC1 and CC2 for power delivery. And as you saw before, indeed the cable has it claims to have 100 watts. It says 100 watts on the cable, but we only have a power supply that can deliver 65 watts, but that's fine. So let me plug it in. This is a USB-C to USB-C cable. Okay, we plugged it in. It came up with a little display there for a second, but it's not drawing any current, so it went off again. And as you can see, 20.26 volts. It's able to negotiate the 20 volts. So that is what a proper power cable does. And we now check out another USB-C to USB-C cable here. As I said, this one came with the I believe with the Asus display for powering it. And all it has on there is super high speed USB revision 3.1, but there is no indication on the plugs that it is anything special. Now this cable, once we plug it into our test board here, interesting note, when you first plug in the cable, the ground gets connected first, and then the power, and then finally they've aligned the pins to do that on purpose. So this cable actually has, the only thing missing is the CC2, but it has everything else, including the shield. So let's have a look what this does with our little test board. Let me plug this into the power supply. And it too is actually, even with the CC2 pin missing, it can actually do 20 volts. So there you go. Now let's try another one. Oh, here we have the one that was actually, I marked it as USB 3.1 Gen 2, and it actually claims, this one claims to have 10 gigabit throughput. There you go, see, put some light on so you can see it. Super speed, but this one is a type A to a type C. So let's have a look what that one does. So this one actually is not able to negotiate 20 volts. It bombs out at 12.4, 12 volts in other words. So let's have a look how this cable, what signals it has. Plug it into the USB 3. You see this one only has a black tongue in it, it's not blue. I've noticed that are different colored ones and it doesn't have any meaning. So this one actually has CC2 is not on. It's a bit hard to see on the camera there, but this is not on. SPU2 is not on, and CC1 is actually not on either. It doesn't have either of those pins on, but it was still able to negotiate 12 volts. I think that is what the the maximum is that it can negotiate with a standard cable if it doesn't have the CC1 and CC2 lines. But we saw one that had only one CC1 line that was still able to negotiate it. So what happens if I plug in an ordinary old USB 2 cable? Let's try this keyboard cable. For good measure, I'll actually plug it into the USB 3 socket. So this one, you see, no CCs at all either. It's just a USB 2 cable. So when I plug this into my power supply, we get 12 volts. Okay, yeah, I seem to vaguely remember now that it can negotiate up to 12 volts when it doesn't have the CC1 and CC2 connected. But it looks like if you've only got one of the CC lines connected, it can still negotiate 20 volts. So I thought that that would be an interesting experiment, because I was wondering why some of these cables had only one CC line connected and what would happen to the power delivery. So kind of now we know, as long as one is connected, it can go at least up to 20 volts, and if there is no CC1 and CC2 lines, it can do 12 volts. So a standard USB 2 cable can actually still deliver 12 volts to a load. Alright, so that's what we have found out now. Okay, so that is what we have, and I personally feel like I can now go through my supply of cables and actually put them in different containers marked, you know, like what capabilities a cable has, you know, 20 gigabits, 10 gigabits, power cables, PD65, PD100. There's even other stuff. We are talking USB 4 starting to appear. It's going to have some additional capabilities. There is a higher power delivery. I think that higher voltages that are going to be coming, more than 20 volts and so on. So it's going to be important to keep up with those things. So this actual board, just for reference, let me go to the display capture here. I actually found it on Amazon. I purchased it on August 17 by the looks of it, and it was only less than $16, but of course you pay some tax and stuff. So I think it's well worth it to have one of those. Anyway, this is just indicating that you can use it to fault find a cable, see if all the pins are connected. Anyway, that is what I have, and I thought I would share that with you guys because it is something that has been on my mind. You know, I've got all these cables, and I've been aware that sometimes I plug in a cable and it's not working, and then I got to grab another one, and now I know why. Alright, so don't forget to, if you liked the video, if useful, to like and subscribe, and I will see you guys later. And I actually have a little video. It'll be a short one, just for I had another cable there that I had to repair. It was broken, but I kind of like it. It was a free one, but it was an extendable one. You can pull it, and any case, I will put that little video there how to repair the USB cable as well. It'll be a shorter one. Okay, so I'll see you guys later. Bye bye.